I'm going to share a screen and put up a few slides and start with some introductions. Okay, so before we go any further, ladies and gentlemen, thank you for coming along. You may have been shown by Zoom before you entered that the presentation, the webinar, is being recorded, and it is. So the reason we're recording it, Chris and I, this is our job. And every so often we like to go back and look at how we do these things. So it's for training, it's for our own CPD. That's why we're recording it. It won't be going any further, and it certainly won't be leaving the inner sanctum of Speed 3D. If you're still concerned about your name or your face being recorded, feel free now to turn your screen off, rename yourself, and we'll edit everything from this point forward out. And thereafter, if you're still not comfortable with being recorded, feel free to leave if you want, but you can always get in direct contact with Chris or I after this, and we can take you through the presentation one-on-one. Okay, fantastic. So to introductions, to those of you that I don't know, Chris Master wants back in, he seems in and out. To those of you that I've never met before, my name's Calum Stewart, and I work in Europe for Speed 3D. And in a moment, I'll go into my background, what I do inside Speed 3D and why I do it, because it has a bit of a knock-on effect, the presentation. But before I do that, I'm going to let Chris Harris introduce himself, because he's probably more pertinent to those on the other side of the Atlantic from me. Chris, do you want to say hello to people? You're on mute, Chris. Still on mute. There we go.
All right. Can everyone hear me? Okay.
Yeah.
Okay. It's always nice to be on presentations that Calum leads. I love to listen to him. He's got a lot of experience, and I'm sure he'll tell you a little bit about how he came to know about speed and some of his background. But you know, when you're talking about things like we're going to talk about today, battle damage repair, I think he's the ideal person to be leading these talks. So I've got my pen and my notepad. I always learn so much from him. By the way, Chris Harris, Vice President of Defense for the Americas for Speed 3D. And Calum, I'll leave it to you.
Okay, thanks, buddy. So some of you, I'm still entering people as I go, forgive me. Some of you may have seen my presentation in Bonn last week at a defense symposium on additive manufacturing. And I gave that presentation, and today was to be somewhat of a rehash of that presentation. But then this morning when I was in the shower, I'm thinking, how can I bring something new? What do people want to hear about? So I've deliberately in the last 6 hours added a new stint to the presentation. So if it looks similar to those that were in Bonn, fear not, there's new stuff. I've looked at those who are attending, and I've tried to make sure I'm talking to the entire audience. So I'm going to try and make sure I'm talking to those in defence, those who work for primes, those who work for service contractors, so we all get something out of the talk. My background, for those that haven't heard it before, although I do seem to say it quite a bit to people at the moment, I'm former British Army, 10 years British Army as a logistician and engineering officer. So for 10 years as British Army, including time in Afghanistan running the main British theatre repair workshop, my concern was getting more kit in the fight more of the time. And the number one hindrance to that, or the enabling factor, was spare parts. Okay, or as the British would call it, ES material, ES mat, class 9 spares. That's the enabling factor for getting more kit in the fight more of the time. And I did that for 10 years. I then joined the Australian Army for 3 years because I was up for a bit of an adventure. So I moved my family and I to Australia, became Australian citizens, and I did the same role in the Australian Army, worrying about spare parts, and getting more kit in the fight more of the time for the troops. During that time, I was asked to explore advanced manufacturing and what effect it could have on equipment availability in the land environment. What does that mean? Can 3D printing actually help us get more kit in the fight more of the time or not? Part of the project meant that this had to be partnered, or the commercial partners had to be Australian, because sovereign capability was seen actually as really quite important. This was back in 2019, so this is pre-COVID, pre-Russia, and pre the recent conflict in Israel and Palestine. So at that point, I'm asking myself, okay, who am I working with? There was a down selection. Speed 3D came out on top. They were an Australian additive manufacturing firm, and actually proximity quite close. And we worked with them I worked with them for 18 months. I was a customer. I'm defense saying, Speed 3D, prove your worth. Can you have an effect? And in that time, I learned a lot. The Australian Army learned a lot. Speed 3D learned a lot. The long and short of it being, while we've found something here that can have a real impact, it isn't going to take over the supply chain. It isn't going to replace the supply chain. But here is a capability that can give a nation a competitive advantage. If I have it and my competitors don't have it, I get more of my equipment in the fight more of the time, and they don't. So how do we harness it? Obviously now, I'm poacher turned gamekeeper. I'm working for Speed 3D in the UK. And across Europe, I call myself the chief disciple. My job is to spread the word, to talk about the opportunity and the impact that digitized and deployable manufacturing have and can have for organizations in defense. Those in uniform and those in industry that support those in uniform are service people. So that's why I do what I do, because I know it works. I know it has an impact, and I have a passion for it. Over the last 4.5 years now, I've deployed with the Australian Army, the British Army, and the Americans, as well as very recently deploying and training Ukrainians, the Ukrainian forces. So I've probably got a reasonably good experience now in this industry, as much as anyone has. And the point of that is the learning that I've gained in the last 4.5 years, and the company Speed 3D has gained in the last 4.5 years. In the next 45 minutes, I'm going to try and cram that learning, as much of it, the real important juices of it, into 4 or 5 slides. Okay, it's not a sales pitch, it's learning. Okay, so I'm going to get cracking. Excuse me as I look at my notes and just find the next bit. Okay, so conscious that some of you may be on this call that are asking, first of all, I know it's Speed 3D, I know it's 3D printing, I know it's about defense, but if you don't know the company and you don't know our technology, this might not make sense. So allow me but 2 minutes to talk about the technology. Thereafter, we're no longer talking about technology. But in short, you can see behind my screen, if you can see my face, and you can see on the slide in front, digitized, deployable metal manufacturing equipment. Other people would call it a 3D printer, okay? And it is a 3D printer, I just don't particularly like the term. Digitized, deployable metal manufacturing. That's what Speed 3D brings to the market, a 3D printer. What's the difference between that and other 3D printers? Well, first of all, both solutions, whether it be the big red box, the warp speed, or the X speed that you see on the slide there, are robust. They don't use lasers. They're solid state, so there's no melting, which means they're really fast. You can pick them up, move them around the world, put them on the ground, and have them up and running with a trained team in under an hour, making parts. And the system's really fast. Making parts 100 grams a minute, parts up to 6 kilograms an hour, depending on the material that you choose. The printers will make a near net shape geometry for you, okay, which means when you make your part, in some instances, it's good to go and you can use that part as it comes out the printer. In a lot of instances, you're probably going to want to heat treat it, and you're probably going to want to machine it. Speed 3D also have that as a technology on offer. It's called SpeedCell. It's a shipping container inside which is all the equipment you would need to do post-processing for cold spray technology. And we always recommend that as part of a deployable solution. Okay, so furnaces, testing equipment, machining equipment. So it's deployable, it's fast, it's rugged, and it's proven, and proven with Defence Forces. That's with, later this year, the British Army. It's been with the Australian Army. Chris has reminded me, thank you, Chris, I've not changed slides yet. Perfectly, yep, the slide change is coming in a minute, but thanks, buddy. We've got the Americans who have used it. We've got the British that have bought a set. The Japanese have recently invested in it. The Ukrainians, the Australians. These are all forces around the world that have been using our equipment. Okay, so that's the technology pitch. That's what we're talking about. Cold spray, fast, ruggedized 3D printing. And for 4.5 years, Speed 3D have been taking this equipment out to Defence Forces around the world. I'll do the first slide change. Here we go. Let's see if it works. Okay, there we go. And so this is what I really want to talk about today. And that's our experience. We will work with Defence Forces, we'll work with primes, with service contracts. And in defence, in that broader defence, we would break the market up into three. We have those who want to use manufacturing or 3D printing for battle damage repair. So that's talking about a solution that can help soldiers, seamen, airmen out in theatre at a reasonably far forward point and make parts that they need now. They need it yesterday. It's a critical part, a part of consequence. And they want to be able to make it out of metal fast. Right now, there's no real solution for that. There's a bit of welding, but welding doesn't make parts. Okay, now that we have deployable, digitized additive manufacturing, battle damage repair and manufacturing for battle damage repair has become a reality. The first thing that Speed 3D get when we enter into that world, and we work with Australian soldiers, British soldiers, Japanese, Ukrainians, whoever, first thing that happens every time, they come to you and they say, this is fantastic, we love the big red box, we love the shipping container, can you make this part for me? And they'll be holding something out in their hands. Or they've got something this big, can you make this for me? Every time. And that's fine, that's understandable. This is step one of the journey when dealing with defence. And that's getting across that what we're talking about here is manufacturing. And it's not a Starship replicator. Okay, so what we're really turning the question into is, can you help solve my problem? I'm just going to admit something. Can you solve my problem? I need a part in order to get my equipment back in the fight. Can you help me? The response that we will take to these soldiers is absolutely, but it's a manufacturing solution. Okay. Speed 3D, when we conduct training, okay, when we conduct training for our soldiers, we will take them through a 5-stage engineering process. First step of that is empathize. So battle damage repair, soldier brings a broken part to a maintainer in the army, and we're teaching the maintainer to say your first step is to empathize. You need to understand what the problem is. Okay, go see the equipment that's broken. See how the part interacts with the system that currently isn't available. Once we understand the problem, we'll understand what technology can solve it, Speed 3D printer or otherwise. And then we can start looking to come up with ideas and solutions and printing prototypes and doing testing. But step one of battle damage repair is to empathize. Now, battle damage repair is very much the purview of the frontline soldier. Battle damage repair is something you do when the supply chain isn't there to back you up. Okay, so what we're talking about here is supply chain hasn't worked, but we need this part. What else can we do? And for the first time, really, in modern defense or in defense history, we can make these complicated parts using additive manufacturing. Speed 3D being one of those technologies that can do it. The other part, or the other two parts of the defense industry, manufacturing for the supply chain, far more complex than battle damage repair. So what we're saying now is, and we hear this from defense primes, the ones we're working with and the ones we're looking to work with, they'll say, in the future, we would like to be able to make lighter parts, cheaper parts, smarter parts, digitized parts, and additive seems to be the way that we should be going. Are we right? Should we be doing additive manufacturing? And the answer is yes, but only if it makes sense commercially. Okay, and which sometimes can come across as a disappointing response. You're not going to use additive if it isn't commercially viable for you. So we need to explore that ground and say, if you want to use additive manufacturing to keep making the same widget for the same vehicle over and over again, just like VW do for making cars, then the business case has to be right. And we'll work with you on that to help you achieve it and understand the business case. But inside that manufacturing for supply chain, there's a few other scenarios. Manufacturing for the supply chain, whether that be a big prime or a service contractor, they also understand that soldiers are at the front line, desperate for parts that right now they can't supply in their supply chain. Soldiers are going to BDR as a way of solving their problems. But if the defense prime can actually do that BDR for the soldier, that seems valuable. So defense primes now have another kind of sub-market within MSC, and that is support to BDR. We're going to make parts back in the home base and launch them forward. They're going to be additively made. They're going to be engineered and tested, not to the original standard, because we know that can't be done. The supply chain's failed. And we're going to launch these parts forward to our soldiers. That's a market that's never existed before. And in the last 6 months, it's suddenly appeared. Why has it appeared? Well, it's appeared because of COVID. It's appeared because of the Russia. And it's only going to get worse, I think, in the years to come. The supply chain infrastructure and backbone, sovereign backbone of nations doesn't exist like it used to. And so we don't have just shelves and warehouses of parts for vehicles that were made 40 years ago, nor do we have the casting foundries that used to exist to be able to just turn on and make these metal parts. But we need to be able to launch them forward and support soldiers. Digitized, deployable manufacturing can do that. And then the final thing for manufacturing for the supply chain, the third element to that is, what's the new value we can add going forward? And this is really interesting. If you're a defense prime, let's say a defense prime in Europe, pick one in your mind, and you know that in the future, you could supply your customers, those in uniform, with technology that means they could make parts for themselves. So let's say the latest tank is due out in a few years' time. And when it's provided, the OEM is saying 20% of our tank can be made additively. Here's the printers to do it. We're going to install them around the world for you. And when we do that, you'll be able to, on call, press print for the part that you need. A part that we designed originally, we've approved, you use our recipe, and when you press print, OEM naturally gets rewarded, but you get your part quicker. You didn't have to move it. You didn't have to store it. You didn't have to account for it. That's where digitized, deployable additive manufacturing is taking the defense market in the future. So manufacturing for the supply chain has 3 aspects to it there. Speed 3D are working in all 3. The final one, bespoke manufacturing. What am I talking about there? Generally, these are more strategic manufacturing requirements, okay? We have a lot of submarines in the world, and a lot of them need complex materials. We've got a lot of spacecraft that need complex materials, okay? And we used to be able to cast them, and we can't anymore. We can't cast them anymore because we've lost institutional knowledge. We've relied on other countries to deliver that manufacturing capability. And in the last 4 years, that's somewhat disappeared. And now we're asking ourselves, wait a minute, how do we make these complex materials again? For these platforms that we must keep going, we need to look to new ways of developing materials. Cold spray additive technology, which in the world of 3D printing is actually one of the latest developed techniques, is proving to be to create some really wonderful materials. Speed 3D have right now at least 3 projects going on that we're involved in, where we are developing old materials in a new way. And the good news is we're achieving better standards than the original manufacturing process. So these are 3 elements of defense industry. Speed 3D are generally known for the battle damage repair, the one at the top. If you go to the YouTube site, if you see our advertising, we're the guys who are standing next to those in uniform. We've got painted up green printers, and we go around the world demonstrating the ability to manufacture in the jungle. That's what we're known for, and we're very good at it. The good news is the other 2 elements of the industry, we're also excelling at. So this is a slide of my own design, forgive me, and I'm going to talk you through it because it's a wee bit messy, but I think it's a useful one. Over on the left-hand side, if we go work up and down, we've got battle damage repair. Okay. Over to the far right, we've got bespoke manufacturing. And that x-axis, let's call it our risk appetite. Battle damage repair way on the left, you've actually, the risk appetite is generally quite high. We're not worried about the consequences so much. Bespoke manufacturing way over on the right, actually, our risk appetite is quite low. If we look at battle damage repair, I've just put out some of the factors that would be important to us. Speed's at the top. Battle damage repair, if you're going to be manufacturing at reach, speed is probably the most important thing that you're concerned about. Down the bottom, the least important thing is the cost of what you're doing. You're doing this because you have a really important part that you need manufactured. Cost isn't the impact right now. Speed is. So that's why speed and deployability are at the top. Quality sits somewhere in the middle because, frankly, when you're in that situation and the supply chain hasn't done what you need it to do and you need a part, good enough, mission ready, on time is better than the original part 3 months late. If we go way over to the far right to bespoke, okay, so you're making materials for the most harsh environments that we enter, space and sea, but you're probably only doing small batch manufacturing. Okay, quality right up there at the top, the most important thing. Down the bottom, speed and repeatability. Speed 3D have experience in this now, which is fantastic. Some of the projects we're doing. And then in the middle, manufacturing for the supply chain. Think churning out vehicle after vehicle after vehicle. Okay, like a VW factory. Most important thing to you is repeatability, cost, speed, and quality. Frankly, there's no compromise in this middle ground. It's a difficult one to be in. And down the bottom, deployability probably isn't the most important thing on your mind. And then we have a red arc going through it all. That red arc's meant to denote just the number of parts that sector is responsible for. Manufacturing for supply chain is going to be taking the lion's share, producing the most parts. Out on the left and out on the right, much fewer parts. Now, when we look to deployable digitized manufacturing, 3D printing industry, generally, one printer would fit in one of these channels, one of these verticals. The lesson here at Speed 3D from the last 4.5 years, we've got technology that now sits across all 3 channels, the same printer. Okay, we know we're fast, we know we're deployable. We also know that we've got materials now that are way beyond what we've been using in the past for our strategic assets. Cold spray manufacturing, when combined with the right heat treatment, is producing magical materials. Let me just fix my screen so I can see more of you. How am I doing for time, Chris? All right. So that was kind of my description of the defense market. So if you're in 3D printing, or you're looking to be a customer, ask yourself where you fit. Which channel is it? And what's the questions you should be asking? And what is it you should be looking from or looking for from your equipment? Is it speed? Is it quality? Is it deployability? Is it material properties? Is it the ease of post-processing afterwards? And then look to the technology that best fits you. Speed 3D, we spend a lot of time asking ourselves where we fit and what we can offer in each channel. Now, let's call that a market analysis. The next bit I want to move on to, the next bit of learning from the last 4.5 years for Speed 3D, is all about capability. Okay. What you can see, but if you can see my face at the moment, I'm not sure if you can, the big red box or XSpeed, the deployable printer, that's just technology. That's equipment. It's something that does something. And when you're selling into defense, we've learned, you're never just selling equipment. You're selling capability. And you need to understand what that capability is. Okay, and what it's made up of. I'm an old, I can't help myself, old army officer. Couldn't help looking back some engineering doctrine. You can see the reference down the bottom. What do I mean by capability? Well, this is straight out of the UK defence lines of development. When the UK look to bring in new capability, these are the building blocks that must exist if you want to take a technology, make it a capability, and then have an impact. And I'll talk through each of these, and then I'll show some photos where which we can take as an example. Okay. So let's start with equipment. Well, that's the easy one, right? You need to be providing something that is safe, proven, and has an impact. We kind of get that. That's what we're offering initially. But now Speed 3D have learned, and you'll see it in any of the press releases, the recent ones about our work in defence. Speed 3D now are not ever really selling just technology into defence. We have learned that it must come with training. Okay, defence forces have really well trained maintenance men and women. Okay, manufacturing, they have some, but actually it's a bit of an old trade and a bit of a dying trade, and it really existed as far as metalsmiths. What we're trying to do is create manufacturers. Okay, so that means design and engineering theory. It means the understanding of materials. It means understanding technical risk assessments. We're asking these soldiers, when we're talking battle damage repair, we're asking these soldiers to take on quite an academic load. Now, we've proven in the last 4.5 years that actually we've been able to do that in some fairly difficult conditions, and with soldiers from different countries, whether it be the Australians, our recent work in Poland, or with the work that we've got coming later next year with the British and with the Japanese. We've got our own bespoke kind of 2-week training package. We've called it a university degree in 2 weeks, where we are bringing the soldiers through what they need to know to be able to do battle damage repair. But it's the same in the other parts of the market, manufacturing for supply chain or the bespoke manufacturing. Excuse me. Taking whoever wants to use a printer and training them so that they understand how materials work with our printers is crucial. That leads to customer success far quicker than just giving them technology and hoping they're going to succeed. If we move along, we'll talk about personnel. Okay, so who is going to be your manufacturer? Again, my bias, I naturally think towards those in uniform. Who's it going to be and how are you going to choose them? I'm going to tie this up with organization as well. Personnel and organization. Who are you going to choose to be your manufacturer? And what effect is that going to have on their career? When dealing with defense forces, or even with primes, we're bringing new technology, new capability, and a new way of doing things. Who are the best placed people to learn it and to take advantage of it? And what effect is that going to have on your organization when you suddenly upskill these people? You want to hold on to them. Okay, so you're going to have to think about retention. It's also really recruitment positive as well, having this new technology and people trained in it. Personnel and organization, it's not one that you can just skip past. Concepts and doctrine. How do you allow yourself to use the parts you've made on this technology? Everyone loves the idea of a Starship replicator. We then explain its manufacturing. We help you become manufacturers. And then someone says, no, you can't use that part. Why not? Well, here's a whole load of reasons why we think you can't use it. But actually, our learning over the 4.5 years are actually, here are all the mitigations, here are all the reasons we should, and here's all the reasons why we can, and here's all the good engineering doctrine and processes behind it. Generally, our experience is most nations, those in uniform, they have this doctrine. But for the last 25 years, 30 years, they haven't been using it. They've been relying on a supply chain that's been masterful in delivering everything. Now, that's not there, and we're asking them to manufacture for themselves. We need to create the policies and the doctrine that they can lean on to be able to make these parts and use these parts. Lots of these organizations will say, we've got that, we can develop it ourselves, we know what we're doing. And generally they get stuck quite quickly. And the experience of a vendor like us who have done this a few times now, we can help them navigate this quite tricky part of the business. Infrastructure. Okay, this is a good one for Speed 3D because we have deployable solutions. If you're in the world of additive manufacturing and you're using additive manufacturing, where are you going to put it? How easy is it for you to set up your equipment and where's it going to go? How much electricity is it going to use? Do you need an inert environment? Do you need your own facility just for the one printer? Or can you rock up with a truck and put it on the ground outside your facility and hook it into a generator? At Speed 3D, we're trying to make that as easy as possible for the customer. That's why we have deployable solutions. Okay, that's why we're using solid state processes. That's why there's no inert gases, protective gases in our systems. You can put inert gases into the system if you want, but we don't set it up for that. All about making that as little a headache as possible. I'll go to information next. All of the idea of digitized, deployable manufacturing sounds great, but you're only really getting the worth out of it if someone makes a design somewhere else in the world and they're able to transmit that design to 10 different printers around the world for 10 different locations that need that part, and they're all suffering the same problem. And then another nation's able to reach in and say, we've got a design that's quicker, lighter, and they're able to share it. And the OEMs are able to say, we've done our homework, we've come up with the master design for everyone, and we're sending that out to the world. I kind of think of it like Independence Day, the movie. I'm going back a bit now. Independence Day, the movie, at the very end, when they upload the virus and they figure out how to kill the ship and they just spread the word to the world how to do it. That's what it's like for digitized, deployable manufacturing. We need the digital thread to bring all of this together to get the value out of it. Otherwise, you're one person manufacturing for one machine for one customer. But if we can bring that together digitally around the world in networks, you've exponentially increased the value that you can offer. Then finally, over on the right, because we've covered organization, logistics. How easy is it to move this equipment around the world? How easy is it to set it up? How easy is it to get the feedstock to the printer? How easy is it to buy the feedstock, to move the feedstock? You need to understand these things before you go committing to a technology. And again, you want to make it as easy as possible for yourself. It will come down to, making sure you get the right packaging so that your product lasts as long as possible. Your feedstock lasts as long as possible. At Speed 3D, we spend a lot of time on developing our materials, developing how we package them, how we ship them, and making sure we have a ready supply for people to access the materials to be able to use it. Where's your electricity come from? It kind of ties in with infrastructure. Can you run it off a generator? That'd be really useful if you can. Understand your electricity requirements. And then that bottom piece I've kind of touched on, interoperability. Okay, defense are not interested in buying a system that's closed off to the world. Okay, and it's one printer that manufactures for one person in one part of the world. Kind of touched that already. You want to be able to tie it all together and with other nations. That's where they get real value for money from their capability. You bring all of that together, and you have a military capability. At Speed 3D, we spend a lot of time thinking how we bring all this together. Here are photos or snapshots that I'm going to talk through that kind of describe some of the things and the points of learning. So here's an image, 5 points for whoever can find me in the photos, describing some of those capability blocks. Okay, so if we look at the top left, we've got a craftsman maintainer, okay, Nathan, and we've got Speed 3D Matt. And Speed 3D Matt is clearly teaching Nathan how to do something. We're on a deployment, we're out in Mount Bundy in the jungle, and he's being supported and he's being taught. Nathan's a craftsman, he's a fitter and a turner, and he was a hobbyist 3D printer before he got into the program. Thinking back to our capability bricks, personnel, picking the right person, picking the right trade, and then teaming up with training as we create this capability. Over to the right, we've got a different soldier on the same exercise. Forgotten his name, that's terrible. You can see him, on his arm, he's got a Lance Corporal stripe. So he's one rank higher than Nathan on the left. He's working on a laptop. So we're now thinking about, these are examples of rank structure. How does the technology and the training and the capability you're creating affect the people in their promotions, their trade streams, and the jobs they're doing? Those arguments are the same for defense as they are for just general commercial industry. He's on a laptop, he's digitally connected, and he has a lathe behind him. So this was us in our very early days learning what deployable manufacturing meant for Speed 3D. It was more than a printer. We needed heat treatment and we needed a CNC machine. You can see the CNC machine actually in the bottom picture dealing with one of the tools that the guys were making. And then over on the bottom left, you've got yours truly when I was still in uniform, and I'm dealing with the heat treatment. I'm not entirely sure what that photo does for my argument, other than it's me there in a photo in uniform, and I wanted to put it in there, showing that I was getting on the tools. But it goes back to the point it's worth talking about when you use cold spray to make parts, okay? A part comes out the printer like a coffee cup. It's strong, but it's brittle, okay? And we use heat treatment to improve that strength, okay, and increase the ductility. There are different types of heat treatment that you can use for cold spray additives, starting with the furnace you see there. That's a basic air furnace that we took out in the field, connected up to a military generator, and we were able to heat treat parts to a standard that were good enough and hard enough to be used as tools. Then you can go into inert kind of vacuum heat treatments, and you can go all the way up to hot isostatic press HIP treatments. As you go up the scale, you're going to get more and more improved material properties, but the heat treatment solution is far less maneuverable and deployable. But cold spray as a process for manufacturing metal allows us to make metal parts that are good enough for the military. Up to now, material properties for pre-existing alloy systems that are now performing beyond rot. Okay, so it's a fantastic way. It's giving us flexibility. Horses for courses. Pick your heat treatment depending on your situation. Here's a more recent example of the Speed 3D team delivering training, okay? Battle damage repair kind of focuses on generally guys in the jungle, photos that you just saw, but actually battle damage repair or expeditionary manufacturing can be in a local facility. Not all wars take place in the jungle or, in the middle of a forest block. Militaries like the British, the Americans, the Australians have for a long time, in times of conflict, think the first Iraq conflict, would use civil facilities to conduct their maintenance and repair and overhaul. They would just commandeer them and use them in times of war. That's still expeditionary manufacturing. The photo you see here is a recent example of Speed 3D doing that. Okay, so we've got soldiers that we're training. We're in a civil facility. We've had to move the capability there and set it up. You can see the warp speed printer, the big red box on the right. That's typically something you would have in a factory or a job shop. Over on the left is the compressor that makes the printer work. And round the back, you've got the powder feeder cabinet and the dust extractor. These are the different blocks that make the printer work. We've got trained professionals training the soldiers. We've got interpreters so that we're able to deliver training to soldiers in other languages. And we're filming what we're doing because we want the soldiers to be able to refer back in time and look at the lessons they've received. When you think back to the capability bricks we were talking about, okay, lots of different examples of logistics, of infrastructure, of doctrine. Okay, this particular example, these soldiers will be using these printers and making parts and allowing themselves to fit it because they need to, they have a requirement now, and they'll be making parts and fitting those parts. How am I doing for time? 47. All right. I think this is my last slide. Another example of creating capability. Okay, Andrew Dogood there presenting metallurgy. So to these newly trained manufacturers in uniform, we're taking them through what it is to be a metallurgist. Not only are you designing parts, but you're designing with materials. And so we need to teach them how to do that. When Speed 3D are working with defense forces around the world, this is what training looks like. I would say 75% of the training you would receive would be in the classroom. The other 25% is just printing. It's knowing how to load the printer. It's knowing how to load your file, press print, and then deal with any fault finding that you may have to, at the user level. The majority of it is actually turning the people into new modern day manufacturers. And it looks something like that. All of these things are what required to create a capability. I'm conscious it's almost 10 to the hour. And I've sped through a lot there. At the beginning, the first half of the presentation, I was talking about what the defense market looks like. Okay, breaking it into three groups. The defense market right now for digitized deployable manufacturing looks like battle damage repair, manufacturing for the supply chain, and then bespoke manufacturing for real strategic material requirements. And talking about what questions you need to ask, what channel do you sit in, which vertical, and what are the questions what are the characteristics of your technology that you require, depending on the vertical that you sit in. We then went on to talk about creating capability for the military in the world of digitized deployable manufacturing, and the different blocks that you as a customer should be asking for, and we as vendors should be delivering. Whether you're in uniform, whether you're a prime, whether you're government research, these are the blocks you're going to be asking for, and that vendors like Speed 3D should be delivering. And if your vendor doesn't have that capability, you should be asking yourself serious questions as to whether you're going to be able to whether you're just going to have a technology or you're going to have a capability. The plan was to finish up without any questions today because we were going to be tough for time. Chris, I think looking at the guest list and looking at the time we've got, we probably could. We've got 10 minutes where we can take some questions. You feel up to it? Happy to take some questions. That's the end of my show. I'll stop sharing. Still not many cameras. Thank you, Chris Masser. It's good to see you. Kitch, Thomas, for sharing your screen. That's very kind. If you'd like to ask a question, feel free to show your face, raise a hand, and ask any questions. I've rattled through that there. There was a lot going on. And I'm only now just able to see everyone who's in attendance. It might be I've stopped people from being able to unmute themselves. If you've got a question, you should be able to unmute yourself now. Chris, on you go, buddy.
Hey.
Good to see you again.
Yeah, good to see you. Fantastic presentation.
You're very kind.
A quick question on the dissemination of, I guess, part information and Are there means in place for the secure transfer of files? I know that cybersecurity is a huge issue right now. Is that something that you and the team are working on, just to ensure that what is produced is reproducible, across the world?
Yeah, absolutely. Great question. So different aspects to that answer. Speed 3D, we make printers, but we know, as you've said, or as I've said, to make it a capability, it's got to be interconnected, right? And so there are many businesses out there who specialize in that product. And I could rattle off 5 or 6 American, European businesses that provide that function. And that's difficult, right? Because if you back one, have you backed the correct one, whatever one you pick? Really, what we're looking for is defense to pick the right horse to back there. Now, if you're a NATO nation, you should be asking the question of RapidE. RapidE is the NATO program that's bringing all this together, that's looking to bring the interconnected, hit the term, and I think I'm using it right, the conduit from which all others will be able to interlink. It's going to allow vendors to interact with defense and different defense forces to interact with each other. That's the idea of RapidE. So there's work in progress. It's not a specialty of Speed 3Ds. And hey, we want to be smart. We want to back the right horse as well. Okay. The good news is we have relationships with quite a lot of these companies now. And if a customer has a preference, the good news is Speed 3D, generally we're able to work with the other company providing that digital access and security. Thank you for the question. Great stuff.
Yeah, awesome. Thank you.
Anyone else? I must have done an excellent job. Fantastic. I'm happy, everyone, to give people 7 minutes of their day back to them, finishing early. At the end of the slide, hopefully I didn't have it up too quick, you will have seen the contact details for myself and for Chris. If you have any questions, or I rattle through that too quickly for you, you are more than welcome to send us an email, ask questions, set up a call, and we can talk you through what you would like to learn or to know. Other than that, thank you for spending an hour with me. I'm conscious there was a lot there I rattled through. And Thomas, Kirk, for instance, you were in Bonn. You may have heard that presentation somewhat twice now. Thank you for staying with us. Otherwise, I look forward to seeing you all around the bazaars and catching up. And for those who will be in Warsaw the same week as Formnext, Speed 3D will be at Formnext, and Chris and I will be at Warsaw at the Defence Conference the same week. We look forward to seeing you then. Thank you very much for your time. Have a good day, everyone.